Hi guys, my name is Terry. In this video, I'm going to go through the additional mathematics for trial exam paper for Kedah for the year 2021. Now we're going to start off with paper 1. So let's go straight to the first question. The first question has two parts, part A and part B. For the first part, Daniel is offering food packet delivery service. The cost price for each food packet is 570. The selling price is 650. On average, he spent 24 ringgit petrol for food delivery per day. So the thing you have to take note is that what is your profit for each packet? Now, if you sell at 650, you bought at 570. So that means you make a profit of 80 cents. Okay, maybe I'll just break it down for you. The first thing is the profit per pack. Yeah, the profit per pack is 650 minus 570. That will be 80 cents, right? So if you sell n packets per day, or if you deliver n packets per day, so you have to multiply by n, right? But he has to spend on petrol, 24 ringgit petrol. So we can write down the function, in this case, Fn. And I'll read the question carefully. Say F represents profit of food packet delivery service. But the one thing the question didn't mention is n. They should say for n packets, yeah, packets of food delivered. Yeah. So if you deliver n packets of food, then your profit per packet is 80 cents times n. So you make 0.8 times n. But however, you have to spend 24 ringgit petrol. Yeah. So you get minus 24. So that will be the profit, yeah, for each delivery. I mean, per day, profit per day. So next, part 2, find the value n to break even. Now, break even means you don't lose money, okay? Because if he fail to deliver any food packet, then he has to spend 24 ringgit on petrol. But it actually doesn't make sense. You ride around, but you didn't deliver anything. All right. So, but yes, what we're saying is average. On average, you spend 24 ringgit on petrol. So to break even, that means your Fn must be 0. Okay, if your Fn is 0, you take 0.8n minus 24, let it be 0. 0.8n equals to 24. N is 24, divide 0.8. Okay, if you're not sure, you can use a calculator. Okay, 24 divide 0.8. It's a matter of switching the decimal. 24 divided by 0.8 is actually 240 divided by 8, which is 30 actually, right? Okay, you can use a calculator, and it's 30. That means he has to deliver 30 packets of food, 30 food packets per day to actually break even. Break even means you don't lose money, you don't make profit. Okay. All right, that is number 1A. Okay, number 1B. This is involving modulus function. Okay, we're drawing a graph of modulus function. So you're given fx and hx, right? So these are two functions. You're sketching the graph of hfx. Now, hfx is a composite function. So composite function hfx means we put fx inside hx. My fx is 3x minus 5. When you sub inside your hx, you get 2 minus 2 bracket. Now remember, you got to think in terms of bracket, okay? So h bracket is 2 minus 2 bracket. If I put 3x minus 5, I need to sub in 3x minus 5, okay? So this will give us, okay, let me write down here, 2 minus 6x plus 10, which gives us 10 minus 6x. 12 minus 6x. Okay, now the thing is, we need to draw the graph. We sketch a modulus graph. Okay. Now, personally, I like to sketch a straight line graph first before I do the modulus. You see, there's a modulus outside HF, right? So to draw a straight line graph, very simple. What we need is 2 points, and the points that we're going to use is the domain here, 0 to 3. So I'm going to start with x and y. I put 0. I put 3. Now, can we do it mentally? You put 0 inside. This will give us 12. And if I put 3 inside, 12 minus 6 times 3. Okay, it's 18. 12 minus 18, negative 6. But, well, you can use your calculator if you're unsure. This one, I'll put a 3 inside. 12 minus 6 times 3, this is -6. Okay, remember this is before you modulus. So it's a straight line graph, right? Let me draw nicely. Let me use ruler tool. Okay, let's put slightly to the left because, yeah, we start from 0. Okay, and then we go 12 a little bit higher. So, okay, I'm going to draw this way across, 12 a little bit higher. This is, yeah, how it looks like. Now, the next thing is, this is your y-axis, this is your x-axis, this is your x. Yeah. Now, I need to draw 2 points, 0, 12, maybe around here. Okay, and 3, 6, 3, -6, maybe around here. Okay, so before you modulus is a straight line. Yeah, this straight line looks like this. Okay, I need to adjust the point and see. Yeah, I'm missing the point. Okay, so let me adjust this line here. You use a ruler is better. I'm using this, not very clear. Okay, there you go. This is my straight line. Now, this is before you modulus. This is a straight line graph of 12 minus 6x. And notice the graph actually intercepts the x-axis. Normally, when you sketch a graph, we need to show the x-intercept and y-intercept. X-intercept happens when your y is 0. So I'm going to let my y be 0. Let's take 12 minus 6x equals 0. 6x is now 12. I bring this over, and x is now 2. So we know it will intercept the x-axis at 2. Okay, remember, I haven't modulus yet. The moment you modulus, what happens? So all the part that falls below the x-axis will now be reflected up. Yeah, it becomes positive. So we're going to take this, and okay, I'm going to draw another line here. Okay, I'll tell you what, I'm going to move this. When you reflect this part here, can you see it's reflected up? It goes over here. All right, now this line, you don't have to draw it. You don't have to draw all the way down. Some people want to put a dotted line, you can. If you don't want, it's fine. Okay, it's not necessary to show that. And the more you reflect up, this one becomes +6. It's over here, right? So I don't think I need to draw a dotted line across. You can see it. It goes down, reflect up. It has a V-shaped graph, and then it stops here at 6. Okay, lastly, state the range. Okay, remember, domain represents your x value, right? So here your domain is from 0 to 3. Yeah, you can see based on this 0 to 3, range represent your y value. Your y value in this case is from 0 to 12. Yeah, largest 12, smallest is 0. So we write our range here. Let me write over here. My range of y, or yeah, y is a modulus of this. In this case, is between 0 to 12. Okay, let's move on to question number 2. So here we have a diagram that shows the quadratic function fx equals to a, x plus 1 squared plus 8 plus 2k, where a k a constant. So you're supposed to find the range of values of a. Now remember, for quadratic function, if the graph is minimum, your a must be more than 0. Yeah, the range of values of a is just a greater than 0. That's it. How about the equation of axis of symmetry? Now I hope you already know how to read equation of quadratic function in the form of, we call it the vertex form, right? If your a is more than 0, your fx will have a minimum, right? And the minimum value is always the one outside your bracket. In this case, is 8 plus 2k. And this happens when the one inside the bracket. Your fx can only be this if this whole thing is 0. When the one inside the bracket, x plus 1 equals 0. Let me write it here. When x plus 1 is 0, x is -1. So this is called the equation of the axis of symmetry. Yeah, the axis of symmetry is the line that divides the curves into two equal halves, symmetrical. So this is your equation of axis of symmetry. Let me write it here. X equals -1. All right. And lastly, you want to find the value of k, right? Now we know based on this, your minimum value is 12. Yeah, minimum value is 12. And this happens when your 8 your fx here is 8 plus 2k. You can see it from here, right? This is your 8 plus 2k is your minimum value, and it's the same as 12. So I'm basically comparing the minimum value I got from my equation here, from this equation here, versus the minimum value I got from my graph. Yeah. So let's bring over 2k is now 12 minus 8, which gives us 4, and k is just 2. Yeah, let me write here, k equals 2. Fairly simple. Okay, question number 3. This is from the chapter Indices, Surds and Logarithms. So this specifically is Surds. Okay, now number 1, we have to find the value of a and b. You're given the first part here. This is a bracket 11 plus surd 3 minus 13 over surd 3 plus 4 squared. So we need to expand and then compare with a, should I say, rewrite it in this format, a plus b surd 3. Okay, the 11, I don't need to do anything. 11 plus surd 3, we just leave it as it is. But the second one, I need to square it. And I need to square them separately. 13, if I square it, I get 169. So this one is minus sign. This is a minus sign, 169. Yeah, and this surd 3 plus 4, I also need to square it. So I'm squaring top and bottom separately. All right, next, I'm going to rewrite surd 3 if I square it. Remember, the expansion of a plus b squared is going to give us a squared plus 2ab plus b squared. So if my a is surd 3, if I square it, I get 3. 2ab, let's do 2 times 4. You can do 2ba. 2 times 4 is 8. 8 times surd 3 is 8 surd 3. And 4 squared is going to give us 16. Now, next, let's simplify this. This will be 169. This will be 19 plus 8 surd 3. Well, to simplify this, the process of simplifying this, we call it rationalizing the denominator. So we can multiply top and bottom with 19 minus 8 surd 3. Remember, you to multiply with is what we call conjugate, right? If this is a plus, we have to multiply with the same number here, but a minus. The reason being because we know if we're given anything in the form a plus b, a minus b, when we expand this, I'll get a squared minus b squared. So by squaring this, I will be able to get rid of the surd 3 here. Okay, so let's just keep 11 plus surd 3. Don't do anything. In fact, the 169, I'm just going to keep the 169. Yeah, and I copy this. But my denominator, I'm going to square it. 19 squared, if you can't do it mentally, use your calculator. 19 squared is 361. All right, so I would suggest you write this down. Write down the working here. 8 squared is 64. Surd 3 squared is just 3. All right, now this 361, I can minus 64 times 3, which is 192. 6. What do you get? 169 minus 192. 361 minus 192, you get 169. And notice it's exactly the same as the number on top here, 169. So we can cancel them, right? So when I cancel, I'm left with 19 minus 8 surd 3. Okay? Yeah, I'm canceling this with this, right? Okay, don't have to show you that. Now, next, let's just expand this bracket, right? So I do a bit slower here. 11 plus surd 3 minus 19 plus 8 surd 3. So since I need to give my answer in this form, a plus b surd 3, 11 minus 9, it will give us negative 8. And then you plus with 8 plus 1, 8 surd 3 plus 1 surd 3 is going to give us 9 surd 3. There you go, I got my answer. My A is therefore negative 8. My B is 9. Okay, by the way, we can actually double check our answer by using this calculator, silver calculator, even the black calculator, you can do that. I'm just going to show you how to use this silver calculator. Now let's take this 169. Okay. In fact, I can just put a bracket here. I take 13 over surd 3 plus 4. All right. And then I close the bracket and I square it. Okay. Now, guys, I got this 19 minus 8 surd 3. right? So I got this, yeah? 19 minus 8. So you can see here, this one. All right, let me highlight for you. So this one, can you see? Yeah, and then you subtract the 11, of course, right? But of course, the usage of calculator is illegal. You should actually show step by step how you get to this answer, right? This calculator is for you to double check, right? Okay, moving on to question B. So for this question, it involves indices, right? Okay, so here we are supposed to express h in terms of k. So I think we can change everything to number in base 2. 32 is actually 2 power 5. There is a h plus 3 here. Then you divide by 64 is 2 power 6. This is 2k minus 1. The result is equal to 8. 8 is 2 power 3. Now, the next thing is, let's expand this bracket. 2 power 5h plus 15 divided by 2 power 12k minus 6, right? So the result, again, is 2 power 3. So let's just subtract this, okay? So when you divide, remember in indices, a power n is a power m times n. And a power m divided a power n is a power m subtracted n. So when you subtract, you have 5h plus 15 minus 12k. The minus 6 is going to give us plus 6. So the result is 2 power 3. So let's just simplify further. This is 5h minus 12k plus 21. The result is 2 power 3. So what we want to do next is to compare the power. I have 5h minus 12k plus 21. The result equals to 3. So I'm finding h in terms of k, so transfer everything over. 12k minus 18. Take this and divide by 5. So when you divide by 5, you will get this answer, 12k minus 18 over 5. So I got h in terms of k. Okay, question number 4. This is from 5 chapter 5 probability distribution. So X is a discrete random variable that represents the household that owns a cell phone in the residential area. The result experiment and the probability of household having a mobile phone shown in the table. Okay, so first of all, we know that total probability is always 1, a sum of all the probability. So this is from 0 to 4. So we add this up. This sum must be 1. So to find the probability of X equals to 2, basically we take total 1 minus the rest. Now you notice you have 2 of 1 over 16 over here, and over here you have 2 of 1 over 4 over here and over here. So we just put them together. All right, so it's basically 1 minus this 1 over 8. This is actually 1 over 2. Well, to make, you can calculate mentally. 1 over 2 is actually 4 over 8. So that will give us 8 over 8. 1 here is 8 over 8, right? 8 over 8 minus 5 over 8 is now 3 over 8. So we just complete the table by writing this as 3 over 8. Okay, I'm going to erase the rest here, right, to make it clear. Yeah. Okay, now, hence, by using table 4, sketch a probability distribution graph for X. Okay. Now, the graph of binomial, this is actually a binomial or general discrete random variable. A discrete random variable graph, they are all vertical line, all right? They take a single value. And if you look at the table again, the largest is 4, smallest is 0. So normally we don't put 0 here. We put the 0 away from your vertical axis so that we can see clearly the value of each probability. So this is 0, 1, 2, 3, and 4. Okay, and if you look at the list, the highest probability is actually 3 over 8, right? So if you can't imagine, we just multiply everybody by 16. When you multiply by 16, we get common denominator as 16. So I times 4, I will have 4 over 16. So I times 2 is 6 over 16. Meaning the highest is, for x equals to 2, is 6 times longer than x equals to 0. So I'm going to estimate this about 6 times longer. This is about 1. So this will be 1/16. This will be 3/8. It's okay to write 3/8 and not 6/16. It's okay. Even if you write 6/16, it's fine because it's sketching and we're not drawing on graph paper, so we don't have to draw accurately. And 1/4 is 4/16, so it's around here, 4 times longer. So it's 1/4. And after all, we only need to draw 3 bars, okay? Only 3 different values, 1/16, 1/4, and 3/8. So the first one is 1/16. Normally what we do is put a cross, we draw a vertical line. Okay, if my line is ugly, just use a ruler, right? Use a ruler. The first line, okay, now this is ugly. Okay, let me do it once again. This is 1/16. I will have to adjust it. Yeah, you guys use a ruler to draw. It's much better. All right, this is my 1/16 over here. All right, first one. Second one, okay, is 1/4. 1/4 is longer. So let me draw a little bit longer. 1/4 from here. We draw vertically down. I'll just adjust this a little bit. Okay, vertical line. Okay, not too bad looking. Okay, next one, we can put a cross here. Okay, next one is 3/8. 3/8 is a lot higher. So let's draw one line. So it goes from 2 all the way up. Yeah, let me adjust it. So to here. Yeah, my line is not very straight. Sorry. Okay. Bit better now. Oh, still not straight. All right, this is better. And next two, just keep drawing. Okay, maybe I can copy them. It's okay. I'll just draw one by one. So let's draw another 2. This one is 1/4 and another 1/16. So let's draw 1/4 here. Another 1/4. Let me adjust it like this. And draw another 1/16. All right, 1/16. There we go. Oops. All right. Well, looks a bit funny. Okay. I guess it's all right. Okay, so that's it. That's my graph of probability distribution for X. Okay, so moving on to part B. This is a normal distribution. For a normal distribution, right? Remember, when they write X follows a normal distribution, this is your mean mu, this is variance sigma squared. So number one, we need to identify what's your sigma, your standard deviation. A standard deviation is the square root of your variance, square root 2 to 5, answer is 15. And we want to find the probability distribution for X, right? For X less than 85. Okay, so number one, remember, X is any normal distribution. To be able to calculate, we have to convert it to a standard normal distribution. And the formula for standardization is X minus mu over standard deviation. So my X here is now 85. So we are Z here. Z is a standard normal distribution. We take 85. We minus mu. Your mu is, in this case, is 80. You divide by your standard deviation, which is 15. All right. Now, next, we need to change this to Z. So 85 minus 80 is just 5. 5/15 is 1/3. Now, usually we just read 0.333. But why? Because your mathematical table can read up to 3 decimal points. I have 3 different ways to show you how to obtain this value. Number one, of course, we use the normal distribution table, right? This one. All right. 0.333, you have to read slowly. 0.3, let me show you here. 0.3 is here. The second 3 is over here. And the third 3, you have to subtract, right? You have to subtract 11 from the last digit. So the way we read this is 0.3707. You subtract 11 from the last digit. So this will give us 0.36. This will be 96. Yeah, 0.3696. Okay, so now the thing is, before that, I need to first do 1 minus, because this is on the right hand side. Okay, this is on the right hand side. You can see 0.33 is over here. Your mathematical table is based on the upper tail. But what we wanted is the left hand side. Yeah, less than. We know this area is 0.3696, but you're finding the value less than that. So in this case, we need to do 1 minus z more than 0.333, which is 1 minus 0.3696. You will get 0.6304. Okay, now this is one way using mathematical table, but you can also use your calculator. Now for this calculator, all right, we have to change our calculator mode to stats, 3 for stats. You go to all clear, just to clear everything first. Then you press Shift 1 for stats. You go to number 5 for distribution. Select 3 for R, right? Now remember, calculator and mathematical table is different. The calculator read R as upper tail. So we press 3 for R, press 0.333, then you get 3696. Yeah, notice you get the same answer, but this calculator gives us more decimal point. Now, if you want to enhance accuracy, you can use 1/3. Actually, 1/3 is a lot more accurate, right? However, because most of the time, they base it on this mathematical table. So, and this mathematical table can be up to 3 decimal points for z value. That's why I will just round off to 0.333 and I use 0.333 on my calculator, right? 333. Yep. You notice there's a slight difference in answer. All right. Another way we can use a calculator is using the latest Casio ClassWidth calculator. This calculator is even better because you don't even have to standardize it. But again, it's illegal. You need to show a proper working and to show standardization from X to Z, and then the 1 minus to get the final answer. So this is how we do it. Press mode. You go to number 7, right? 7 for binomial. You can see from here, mode. I can show you this again, mode. You go to 7 for distribution. Then you go to normal C. All right. So in fact, this calculator, we can just key in our lower limit. So when we say X less than 85, that means it goes all the way. And this is before you standardize. The mean is 80, 85 is over here, right? The lower tail is all the way to infinity. We say negative infinity. The upper tail is up to 85. So we put lower tail as negative 999, or even 99 is good enough because we do not know what is your, I mean, it goes to infinity, right? What do you put for infinity? You put 999, yeah, a big negative number. And your upper tail, in this case, we put 85. Your standard deviation is 15, and your mean in this case is 80. All right, now this will be a super accurate answer, 0.6306. Now you notice I got 6304, which is close. All right, it's just for you to double check your answer because there's again the error or the difference in the answer is because we rounded off this to 3 decimal point for C. And again, why we get the different answer? Because why use 3 decimal point? Because the mathematical table can read up to 3 decimal point. All right. Okay, question number 5. This is from chapter 5, progression. So now, diagram 5 shows 7 circles formed from a piece of wire with the length of 140 pi cm. The radii of the circle differs each other successively by 2 cm. Now, the problem is we do not know what is the radius of the small circle. In fact, we're finding the radius of the small circle. So maybe I can list out for you. the radius of the small circle, let's say we write here is radii. Radii is plural form of radius, r. Now, the difference is 2, successively like 2. So you put r plus 2. The next one is r plus 4, and so on. But here the question says you use a piece of wire, you bend to make multiple circles like this. So that means that the length of the wire is actually your circumference. And circumference is given by 2 pi r. So the first one is 2 pi r, second one will be 2 pi r plus 2. Next one will be 2 pi r plus 4. Okay, we don't need to write everything. I just want to show you that we can find a common difference from here. If this is your T1, this is your T2, your common difference D is T2 minus T1. Now, for my T2, I'll just expand this straight away. So I got 2 pi r plus 4 pi minus T1, which is 2 pi r. The difference is now 4 pi. Now, one thing, if they give us the length of wire, which is 140 pi, we know that the total length must be total sum of an arithmetic progression. In this case, arithmetic, we can see it increases with a common difference. If you go and multiply this inside, this is going to be 4 pi, and 4 pi minus 2 pi, the difference is still, 8 pi minus 2 pi, 8 pi minus 4 pi, sorry. This is 8 pi here, right? You minus your 4 pi. This one is 4 pi, 2 pi r plus 4 pi. The difference is also 4 pi. So it is arithmetic, but how many circles do we have? We have 7 circles. So we know S7 must equals to 140 pi. Okay, so the next thing is I need to find R. Yeah, guys, I need to find R. So which is the radius of the smallest circle. Now we know Sn, if you are not sure, let me write down for you, is n over 2, 2a plus n minus 1d. This is the formula for sum of the first n term of an arithmetic progression. So we did 7 over 2. My a is now 2 pi r. Yeah, 2 pi r. N minus 1 is 6. My common difference is 4 pi. The result is 140 pi. Okay. Well, the pi is a bit annoying. You've got to eat them, right? So we can just divide everybody by 4 pi. If you want, you can just, well, maybe I multiply the 2 over. Yeah. Okay, this one is 4 pi r plus 24 pi, right? And I take 140, I divide by 7. 140 divided by 7 is 20, 20 times 2. Yeah, 140 divided by 7 times 2. There you go, 40. Okay, so this is now 40 pi. And I can still simplify this by dividing everybody by 4 pi. So r plus 6 is now 10. And my r is 10 minus 6. The difference is 4. That means the radius of the smallest circle is just 4. Okay. Moving on to part B. They say the number of complete circles can be formed if the original length of the wire is 200 pi. So now we have to use the Sn formula again. But this time, I need to find n, number of complete circles you can form. So we know Sn is now 200 pi instead of 140 pi. So let's use n over 2 bracket 2a. My a is now 2 pi r, and I know my r is 4. So we take 2 of 2 pi r. My r is now 4. Okay, plus n minus 1. Common difference is also 4 pi. The result is 200 pi. Okay, now for me, I don't like a pi, so I just divide everybody by 4 pi, right? You can actually divide, or you want to times over first, also can. I multiply the 2 over, all right, this will be 2, this will be 16 pi. Keep the 4 pi first, just don't need to expand, keep it first. You times the 2 over, this is 400 pi. Now let's divide everybody by 4 pi. So when you divide 4 pi, this is 4, this is n minus 1, this is now 4, it's 10, sorry, it's 100, right? 400 pi divided by 4 pi is 100. So what we have here is a quadratic equation, but it's not a nice number because if you expand this, n squared, 4 minus 1 is 3, 3 times n is 3, n 100, I bring it over, is minus 100. So, and we can't factorize this. If you work out the factor of 100, is like 101. So we can do 50 and 2, 50 and 2, 25 and 4, yeah, 10 and 5, or maybe 20 and 5, 20 and 5, 10 and 10. None of this will give us 3, yeah? So you cannot factorize. So if you can't factorize, what we do, we use quadratic formula. N equals to negative b plus minus square root. B squared is negative 3 squared, which is 9, minus 4ac over 2. All right. So now let me continue here. My n is therefore minus 3 plus minus. This is 9 plus 400. Right? You can't do mentally, just use a calculator, right? Minus 3 squared. Yeah, minus 3 squared minus 4ac, negative 100, 409. Yeah. So this is square root 409 over 2. Now we know n can't be negative. The number of circles can't be negative. So we take the positive value. That means, notice you have a plus minus. We drop the negative straight away. We take the positive one, which is minus 3 plus square root 409 divided by 2. And I got 8.61, right? So n must be 8.61. 8.61. You want to write more decimal also can, doesn't matter. But the thing is, the point of the matter is, I don't have enough to form 9 circles. I only have 8.6. That means I do 8 circles. 1, 2, 3, 4, 5, 6, 7, 8, and a little bit more, right? Not complete. So the question wants a complete circle. So number of complete circle, you don't have to write so long, to just write 8. Complete circles is just 8. It's not enough for you to make 9, right? Okay, question number 6. This is from chapter 8 vector, right? So you have a diagram such that it's a triangle. We have AB plus BC equals 5I plus 3J, and it's supposed to express M in terms of B. So one thing about vector, you can write in IJ form, you can write in column vector. Personally, I like column vector because IJ have to write I, to underline J, underline it, a lot of work, right? And what is AB plus BC? Well, if I go from A to B, followed by B to C, my resultant vector is just AC. So we can say your AC, based on this information here, is now 5, 3. Again, I like to write in column vector. It's easier, don't have to underline and write more letters. Okay, and what is AC? Well, I hope you all know this, a position vector. If I say I want to go from A to C, I have to go from A to O, O to C. Position vector is always respect to your origin O, and then you go to C, right? So A to O, O to C, right? So personally, I don't like to write this. I like to write OA, because AO is negative OA, it's opposite, plus OC, so it's just OC minus OA. Now, this is applicable to everything. Like if I give you PQ, it's always the second alphabet Q respect to O, minus the first alphabet P respect to O. If I give you RS, it will be OS minus OR, right? So I hope you can write this directly. This is OC minus OA. Now, in position vector, right, OC is just another way of expressing coordinate of C. If your coordinate is HM, then your position vector of OC is HM. We write in what we call column vector or translation vector, right? Now, what is OA? Well, my OA is this, minus 3B minus 2H. And this result is 5, 3. So what I need to do is put them together, minus minus a plus. So it's H plus 3B and M plus 2H. Put them together, the result is 5, 3. Okay, now here's the thing. I want to find m in terms of p. If you want m in terms of p, I must get rid of h. So let's compare our I component. My h plus 3p is now 5. If you want to get rid of h, we make h as a subject, 5 minus 3p. Call this equation 1. Then you compare your j component. Your m plus 2h is now 3. Call this equation 2. When you sub equation 1 inside equation 2, we can get rid of h. Your m plus 2, don't write h, write 5 minus 3p, the result is 3. Okay, let's expand this. This will be 10 minus 6p equals to 3. We are supposed to make m as a subject, Malaysia as a subject. So bring the 6 over, negative 6 bring over, positive 6, 3 minus 10, negative 7, m is 6p minus 7. There you go, you got m in terms of p. Okay, question 7, this is a linear law question. All right, so number 1, linear law from 4 chapter 6. You're given the graph of log 10y against log 10x, okay, x plus 1 actually. So the distance of AB is now 5 units, and point A lies on the y-axis, log 10y axis. So I can draw a line here, draw a line here. Now in coordinate system, we understand that if B is 4, 6, that means I'm moving to the right by 4, I'm moving up by 6. Okay, 4 to the right, 6 up. Now, how do you find coordinate point A? Number 1, I know if B is 4 here, that means this length from here to here is 4. Now, your height here, we can find, right? So to find the height here, up to you, you can call it h. Your height is what? 5 square minus 4 square, square root. This will give us 3. And to find coordinate point A, right? The y coordinate of point A, we start from 6, we go down by 3. This is 3, yeah? Your difference is also 3. So your y coordinate point A is 3. Therefore, the coordinate point A will be 0, 3. Remember, coordinate we write axis followed by y. If it lies on the y-axis, in this case, you don't go left, don't go right, you stay 0, you go up by 3. Okay, next I need to express y in terms of x. Okay, so you can write here your coordinate is 0, 3. Okay, to express y in terms of x, I already can see from my graph, I can find 2 things from my graph. Remember, linear law, 2 things you can find from the graph. Number 1 is your gradient, number 2 is your y-intercept. So my gradient, I can see my vertical distance is 3, horizontal distance is 4, my gradient is 3 over 4. And my y-intercept is here, the coordinate, y coordinate point A, in this case is 3. So we can use y equals to mx plus c, right? And what is your big Y? Well, on my big Y, I have log base 10 y, all right? Then this is 3 over 4. On my big X, I have log base 10x plus 1. And the outcome, and then you have to plus a 3, okay? Now, my goal is to find y in terms of x. To find y in terms of x, I must get rid of the logarithm, right? So the left-hand side really have a single logarithm. Remember, the idea of getting rid of logarithm is that if I have log 10y equals log 10x, if I have single logarithm, my y must equals to x. But on my left-hand side, I really have a single log. But right-hand side, I don't have a single logarithm. In fact, this 3 here doesn't have any log. So what we can do is we can put a log 10, 10 at the back. Why log 10, 10? Log 10, 10 has a value of 1. Remember, 10 power 1 equals to 10 here. This is 10 here, right? So log 10, 10 is 1. If you don't believe me, you can use the calculator, LG 10. There you go. It's always 1. Now, next, we can bring the power up. Transfer the power up. Right, so when you bring the power up, this is x plus 1 power 3 over 4, whereas this is log 10, 10 power 3, which is 1,000. Now in logarithm also, you know these are the you want to call this the law, the third law of logarithm, log ax to the power n, we can bring it in front. Now we're doing the reverse now. Instead of bringing it in front, you're bringing it out. Yeah, because we are combining it. We're combining to a single logarithm. We don't want to have any number in front, so we bring it up instead. And also, the first law of logarithm is that if you have log ax plus log ay, we can combine them and we write log base a x times y. So likewise, I'm going to combine this. Okay, but I'm going to put 1,000 in front, 1,000 in front, and x plus 1 power 3 over 4 at the back. So this is log 10 1. So now I've got y, log 10 1 on the left, log 10, 1,000 x plus 1 power 3 over 4 on the right. Basically, just compare them. This is 1,000 x plus 1 power 3 over 4. There you go. I got y in terms of x. Okay, question number 8a. The first part is coordinate geometry. Part A is what do you call it? Form 4, chapter 7. Right. Okay, here we have 3 straight line on Cartesian plane. Straight line PR is parallel to y-axis, right? When it's parallel to y-axis, like this, it's parallel to y-axis, this line has equation of x equals to h, all right? And h, p, q are constant. Okay, they're given that PQ and Q are perpendicular to each other. PQ and Q are perpendicular to each other. Express Q in terms of P. Now we know when two lines are perpendicular, we know the gradient M1 times the gradient M2 equals to -1. But first of all, I need to find, let's say, gradient of PQ. Now, based on this equation, look at the PQ. Y equals to mx plus c. So what is your M? Your gradient, PQ, M is now K. For gradient QR, right, I need to find the y coordinate point Q first. I can see from here, when you look at your y equals mx plus c, your y coordinate, y-intercept actually is now Q. So the big Q here has a coordinate of 0, Q. Now, you don't really need to do that. You don't really need to show that. I just want to let you know that my y-intercept is 0, Q. Now, why is it important? Because to find the gradient of QR, I need to use negative y-intercept over x-intercept, which is negative q over h, right? So now next, because I know these two lines are perpendicular, the gradient multiplied together must be -1. So let's take PQ times QR. The result is -1. And what are we finding? We're finding Q in terms of h. So we can just multiply up. Well, in fact, we can cancel the negative, cancel negative here, cancel negative here. Just multiply over. My Q is now, h goes up, k goes down, Q is now h over k, right? Pretty easy. Okay, moving on to B. So this one involving the divisor of line segment, or we call it the ratio theorem. Now, here, same chapter, coordinate geometry. Here, they say this diagram shows straight line that passes through RST, whereas divide the line segment according to ratio of n:n. So the first thing is, remember the ratio theorem, if you like to call it, is given as nx1, mx2 over n plus n, and y1 and y2 n plus n. Now, you don't really need to memorize the formula. The most important thing to understand that the ratio and the coordinate must be opposite. For example, n here, I must multiply with the coordinate on the left, the opposite side, 1k. And here, I must multiply with the coordinate on the other side, which is r4h, right? So let's start off by comparing the coordinate one by one. We start off with the x coordinate. My x coordinate here is 3. Let's take n multiplied by 1. You can write 1n, right? And then m multiplied by 4. So m4. You can write 4m. Your total ratio is m plus n. So what we want to do is we want to find, I think we can find the relationship between m and n. So I multiply over, this is 3m plus 3n. This is n plus 4m. All right. So let's arrange it. Bring the n over, bring the m over. 3n minus 1n is 2n. 4m minus 3m is 1m. So I think we can find exactly what's the ratio, but we have to change from what we call the equation form, right? You divide it, you get 2/1 equals m over n. Now, actually, when I bring the n down, it's actually 2, but we write this as 2/1 so that we can write in the form of what we call proportion. Yeah, proportion are basically two equivalent fractions. And from here, we can see that m/n has a ratio of 2:1. So I do this first so that once you get this ratio, I can now link the second equation because we are finding k in terms of h, right? You can see there's a k here, there's a h here on the y coordinate. So I'm going to go on and work on my y coordinate. My y coordinate is 5, right? Is 5 here, and it's now n times k. I'll just write this as nk. N times k is nk, all right? And then I'm going to take m times 4, which is m h, divided by total ratio m plus n. Okay, actually, now that I know the ratio is 2:1, right? I don't have to write this anymore. My n is now 1. My k is now, my m is now 2. This is 1. You want, you can write 1. This is total 2 plus 1, which gives us 3. So let's multiply over 3 times 5, 15, k plus 2h. I'm finding k in terms of h. So bring the 2h over, k is 15 minus 2h. There you go. You got k in terms of h. Okay, let's move on to Form 5, Chapter 1. Question 9 is Form 5, Chapter 1, circular measure. So here we have a circle, APP is a circle, and a sector of OCD, a circle respectively centered. O, area of the sector OCD. OCD is the whole thing, right? Is equals to area of circle. Okay, I'm going to write here area of circle OCD equals area of circle. And what are we finding? We're finding angle AOB in gradient. We can let AOB be theta. Now, area of circle sector OCD is half. My radius is measured from here to here, which is going to give us 8, right? So half, your radius is 8. You square it. Your angle theta is unknown. I'm going to put theta here. All right. Now, next, I would have to use area circle, which is pi r squared. Your radius is 2. You square it. So 8 squared is 64. 64 divided by 2 is 32. This is 4 pi. My theta is 4 divided 32. 4 divided 32 is 1/8. So it's pi over 8. Now, well, the question say use 3.142. Remember, be careful. Don't use a calculator pi. Use 3.142 because sometimes the answer is different when you use a calculator pi versus 3.142. So I got 0.3928. I think 3928 is good enough for significant figure. 0.3928. Okay, in gradient. Okay, how about perimeter of the shaded region? Okay, your shaded region consists of 4 parts. So let me just highlight for you. The first part, of course, you define length of this arc. Second part, length of arc CD. Third part, this is 6. This is also 6. Okay. Well, your perimeter, let me start off. This is, by the way, this is part A, this is part B. I already know the length of arc. I know the radius is 2. I know the theta. So you can put 2 times 0.3928. This is to find the length of arc AB here. Then I find the length of arc CD. Now I know CD has a radius of 8. Remember, I'm using the formula S equals R theta to find length of arc. Yeah, length of arc is your radius multiplied by your angle in radian, theta in radian. So this is 0.3928. Then you plus 3928. Then you add 2 more parts, which is 6 and 6. So we can just say 6 times 2. Yeah, or you can write 12. Now to make a life easier, do you realize that these 2 are 2 of this, 8 of this, you can put together is 10 of this? Yeah, you can actually think 10 times 3985. So you switch the decimal point 3.93928, right? And then you plus with 12. Okay, So I got 15.93. You want to write 928, go ahead, no problem. No problem writing more. All right, but 4 significant figure is good enough. So I write 15.93. Yeah, it's okay if you write 15.928, no problem. Okay. Okay, question number 10. This is from 5, differentiation, chapter 2. So find the value of h and k, given that when you differentiate this, you get this. Okay, so first of all, I hope, because some of you may actually learn to differentiate only using AXN. So now I'm using another formula, a slightly faster formula. We call it a reciprocal form. When you differentiate this, we put a negative in front. We copy a times n, copy x, increase the power by 1. We use this in the event that x is below. Now, I know a lot of people will bring power up, right? Then you have to differentiate and bring it back down, which I think is a bit slow, right? Because when you use in this form, your answer is straight away in the reciprocal form. So let me show you here. When you differentiate the first one, I'm copying this again, 3 over 2x4. This is 5 minus x power 5. This is the reciprocal form. So when you differentiate, I'm going to write here, negative in front. Yeah, I'm using this formula here, a times n. So I'm using 3 over 2 times n. My n is 4. I divide by x. I increase the power by 1. So it's 4 plus 1, you can write 5 straight away. All right. Now, second one, I'm using composite function. I hope you remember composite function, y equals to k. Now, this one can be anything. Fx can be any linear or non-linear function. When you differentiate, you bring the power down, you copy the bracket, you reduce the power by 1, and you differentiate whatever inside the bracket. So here I bring the power 5 down, I copy my bracket 5 minus x, I reduce the power by 1, 4, and when I differentiate inside, I have a negative 1. So let's take this and simplify. This is negative. 2 and 4 cancel, left with 2, 2 times 3, I got 6, x power 5. And I have a negative 5 and a 5 minus x power 4. So what we're going to do is we're going to compare this with what we have over here, the whole thing here. Look at this, the whole thing over here. All right, I'm going to write here, this is now h, x power k. This is plus h minus h plus 1 and 5 minus x k minus 1. Now, actually, I feel that the question gave too much information. It's just not necessary for you to do both, because even if you do the first one, you'll be able to find your k and h. Now, look at this. Your h is what? By comparison, we can straight away see, okay, I'm just going to highlight for you. This is my h, right? And this is my k. Look at the power, right? So by comparison, yeah, my h is negative 6, my k is 5. Now, if you don't believe me, you say, oh, I want to compare the second one as well. Yeah, you can do that. H plus 1 is negative 5, all right? And if you compare your k, see, it's going to be the same. When you put it all here, you compare the second one, h plus 1 is negative 5, your h is still negative 6. And if you compare the second one, your k minus 1 is now 4, your k is still 5, right? So it's just not necessary actually to do both. You do one, you get your h and k straight away. Okay, part B. If point A lies on the curve, but the sign of dy dx remain unchanged, but the gradient decreases before A and increases after A. State the value of d2y dx squared at the point. Okay, so what do they mean? All right, so now let's say we have a point, right, on the curve. The gradient decreases and the gradient increases. Okay, one of the things you can do is this. You know there are 3 types of turning point, and let me explain briefly. The first one is a minimum point. A minimum point, the gradient goes down, horizontal, and up. So your gradient is actually negative, 0, positive. So the gradient is actually increasing. Your maximum, your gradient is positive, 0. Your gradient is decreasing. The third one is called point of inflection. Actually, point of inflection, there are 2, non-stationary inflection and stationary inflection. But your textbook tend to point to only stationary inflection. So you know what's the difference? Minimum is all three, right? Well, minimum dy dx is 0, but your d2y dx squared is now more than 0. Maximum dy dx is 0, d2y dx squared is now less than 0. Point inflection, like I said, you can have a non-stationary inflection. Your dy dx can be non-zero, but at form 5 level, most of the time they focus on stationary inflection. Dy dx is 0, d2y dx squared also 0. Okay, to answer this question, the question says that the gradient decreases before and increases after. So this one, your gradient, when you have a point of inflection, by the way, it can be like this, horizontal, like this. It can also be like this, horizontal, like this, right? A classic point inflection is your cubic function. Cubic function, it goes up like this, or it can go down like this. Okay, so the gradient decreases before and increases after, right? So which one? You notice your gradient here is decreasing, but the gradient here after that is increasing. I know some people get a bit confused with minimum. Minimum is my gradient increasing or decreasing? Actually, my gradient is increasing. You see, your gradient is negative here. Okay, picture this. My gradient is negative, right? Negative here. Then it goes from negative to 0 to positive. So your gradient is always increasing. Yeah, it goes negative, 0, positive. If today I were to draw my dy dx versus x, the gradient is like this. For maximum, on the other hand, my gradient goes from positive to 0 to negative. So positive to 0, negative. So my gradient is actually decreasing, right? So, but point of inflection is unique because if I draw my graph like this, they say the gradient is decreasing before A and increases after A. Can you see? Your gradient is slowing down to 0 here, then it increases again. So there's only one statement for this, all right? Just to test you on the concept. The question says, state the value of d2y dx squared. So your answer is d2y dx squared is equal to 0. Only one answer, right? That's very long. You have to explain the concept. Okay, let's move on to number 11. This is integration. Okay, the first part, A, you're supposed to integrate this and the result equals to this. Okay, well, we're just finding the value unknown. So first of all, you need to expand this bracket. This will be x squared, right? This is 6x minus 3x, which gives us 3x. And the last one is minus 18 dx. Let's expand first. Number 2, let's just integrate x power 3 over 3. Remember, when you integrate ax power n dx, we copy a, copy x, increase the power by 1, divide by the increased power plus c. So the second one is going to be 3x squared over 2. And if you have a constant, when you integrate a constant, just add an x. So last one is negative 18x plus c. So we're going to copy this. This is 1 over 3x cubed. This is your m over 2x squared. And last one is your mnx plus c. It's quite similar to the question earlier for differentiation. We're comparing, but here we're comparing for integration and comparing unknown to find the coefficient of x squared and x to find m and n. So when you compare x, you can see m over 2 is 3 over 2. Again, let me highlight for you. I'm comparing this with this, the coefficient. So my m, Malaysia, m is just 3. Now, when you compare your constant, this is x squared, by the way, you're comparing x now. My x in this case, let me highlight for you, negative 18 equals to negative mn. So negative mn equals negative 18. I know my m is 3. I can cancel the negative, right? Cancel negative. My m is now 6. Okay. Moving on to part B. All right. So diagram shows the curve y equals fx, straight line y equals gx intersect at point A. So given that integration 0 to p fx dx is 12, find the area shaded region in terms of P and Q. Okay, I'm going to draw the dotted line downwards here. This is your P, this is your Q, right? So well, what we can do here is this. We know the integration of 0 to p fx dx. That means we are talking about this area here. Yeah, we're talking about this area here. So this area under the graph is just 12. Okay, let me write down here. This area under the graph is 12. Okay, and we can still find, we're finding the area shaded region. So we can still find this area here. Let me draw for you. It's a trapezium. You minus this integration, so you get the shaded region. Now your trapezium, if you measure from here to here, this length is 8. And the length from here to here is now B. And your height here is now Q. Now we know this area is 12. So let's use formula for area trapezium, right? You're supposed to find the area in terms of P and Q. Area trapezium is half sum of parallel sides times height, which is P, minus this area integration 12. Okay, so let's multiply half inside. Half times 8 is 4, 4 times P is 4P, half times Q times P is going to give us half PQ minus 12. There you go. You can write in any sequence, so you can write half PQ plus 4P minus 12 as well. Okay, let's look at number 12. Okay, so 12a, this is Form 5, Chapter 4, Permutation Combination. So show that NC0 equals to 1. Okay, first of all, you need to know this formula is given in exam. NCR means out of n item, I choose R item. Is given by n factorial divided by n minus r factorial r factorial. So if you want to show this the first part, NC0, you need to think n factorial, n minus 0 factorial, 0 factorial. And remember, 0 factorial is 1. And if you're not sure, you can use your calculator. 0 factorial is just 1. And now you're left with what? N factorial. N minus 0 is still n. So you're having n factorial divided n factorial, which you can cancel out. Your answer is 1. Okay, second part. Sulaiman has 2 cell phones and 3 keychains. Find the number of different ways Sulaiman can attach the keychain and the cell phone. Okay, actually this one is using the idea of multiplication principle, right? You don't need to use a combination or permutation. It's just multiplication principle. So he has 2 cell phone and 3 keychain. So you got to think like, okay, my cell phone is, let's say, A and B. My keychain is BQR. My question is, how many ways can you attach the cell phone to the keychain? So there are 2 here. 1 times 3, 2, second one times 3. So just use multiplication principle. 2 times 3, answer is 6. Yeah? Very simple. Okay. Moving on to B. Okay, now I personally think this question is, they just add in the sign language code to confuse the student, right? Actually, it's quite straightforward. Yeah. So diagram shows the sign language code used in Malaysia. A secret command involves 8 hand gesture from the keyword Malaysia using the sign language to be used by a spy. Find the number of different signals he can use. Okay, the word Malaysia. Now, here's the thing. This is the part of the new KSSM syllabus. The word Malaysia has repeated, or should I say, identical letter. So when you have identical letter, right, Malaysia, you got 3 letter A. The rest are M, L, Y, S, and I. So 5 different letter, 3 identical letter A. So total you have 8 letters. So how many ways to arrange 8 letters in a row? Answer is 8 factorial, right? So I'm just using like, okay, A from here, N from here, but don't really methods, right? Because after all, they're all distinct sign language for different letter, right? So we have 3 identical letter A. Remember, you have to divide by 3 factorial, because when you arrange the word Malaysia like this, it can be, if it's distinct letter, this is, let's say, A1, A2, A3. But so when you arrange it, let's say I don't put, this is A1, A2, A3, this one is A1, A3, A2. When you remove the this, what do you call it, superscript, subscript A1, 2, 3, it doesn't matter, it's the same. It appear to be the same. So we tend to have additional arrangement, right? In fact, we have three factorial different arrangement. Yeah, because your A1, A2, A3, they are actually 3 factorial ways to arrange them. So that's why when you have identical letter, you always have to divide by the number of times the identical letter appear. So here I take 8 factorial, I divide by 3 factorial. Guys, my answer is 6720. Yeah, 6720. All right. Okay. Then last one for permutation and combination. This is a very interesting question. Okay. So diagram shows beehive built by Rose Nizam to grow chili. So calculate number of quadrilateral on the ridges. Okay, so if you view from the top, what we see is a diagram like this, right? And you notice you count, there are 5, right? 1, 2, 3, 4, 5. It's a square actually. 1, 2, 3, 4, 5. Sorry, my line is not very straight. Okay, so they say now there is the thing you understand. Quadrilateral means it can be rectangle, can be square, right? So first of all, I want you to understand that I can choose like this point over here, and let's say this point over here, then I can form a first quadrilateral. I can even choose this point over here, and I choose this point and this point over here. So I'm actually forming a quadrilateral like this, right? So the key is, out of how many here? How many points do you have on the left? You count 1, 2, 3, 4, 5, 6. I got 6 points here. I need to choose any 2. When I choose any 2, I can find the height, if you like, right? And how many points I have horizontally? Let me just highlight for you. 1, 2, 3, 4, 5, 6. Again, I have 6 points. I choose any 2, right? It can be 2 that is close to each other like this. I can choose the other 2. Vertically, I choose this point and this point. Horizontally, I choose this point and this point. So I get a rectangle like this, right? So it can be a square, can be a rectangle, doesn't matter. But the key is your vertical, you have 6. I choose any 2. Horizontal, I have 6. I choose any 2, right? So that will give us 6, choose 2. Use your calculator. In fact, you can square it. You square it, you get 2 to 5. It's 15 times 15. Answer 2 to 5. Yeah, very interesting question. Yeah. Okay, let's move on to section B, question number 13. This is form 4, chapter 3, a system of equation. So here we have to form 2 equations and solve them simultaneously. So we start with this. The farmer has a rectangular piece of land. He planted papaya and pineapple trees on the land as shown in the diagram 13. So given the area of papaya plantation is 115, perimeter pineapple is 24. Find the area of pineapple plantation. Okay, so now I think number 1, I'm going to write here, I'm going to form the first equation. Your first equation is area planted with papaya, which is this area here. Let me just highlight for you. Papaya is this, should I say this area here? This is your papaya. We need to take a rectangle, the bigger rectangle minus the smaller rectangle. Now, the first thing is, what is the length of this big rectangle? Well, the big rectangle is 15 times x. Okay, then you got to subtract the small rectangle, which is here, this papaya, this is a pineapple here. Well, the length of your pineapple plantation here, if this is 15, the other one is y, yeah? This is 15, this is y, the difference is 15 minus y. And if this is x, this is 5, the width is x minus 5. So we need to take 15 x, subtract with 15 minus y,
multiply with x minus 5. And the result must equal to 115. Now, I'm not sure what to do with this, so I can leave it out first, because I know some of you may want to expand first, because when you expand first, I think the working might be a bit longer, so I'm going to leave it out, call this equation 1. So let's look at the second one. Perimeter of the pineapple plantation is 24. So perimeter means we take the length of this side, we times 2, because we have top and bottom, and this side we times 2 because you have left and right. So your perimeter is, can I write 2 of 15 minus y plus 2 of x minus 5, and the outcome equals 24. Now, for me, I like to divide by 2 to make this smaller. Yeah, so I don't have to expand and simplify further, right? And now, remember, if you to decide what to make as a subject, we look at how two things are, whether you can avoid fraction or we have fewer substitution. In this case, I think both cases, both x and y, you could avoid fraction. But if you look at the substitution part, if I make x as subject, I would have to substitute twice. If I make y as a subject, I only need to substitute once. So I think it's better to make y as a subject. So let me do a bit slower here. I bring the y over to the right. I bring the 2 to the left, 12 to the left. So your y is now x 10 minus 12, which is 2. That's my equation number 2. Okay, so I have y as a subject. So now let's sub equation 2 inside equation 1. My equation 2, this is 15x minus 15 minus your y. Remember, there's a negative in front, so it's minus x plus 2. I hope you guys understand what I'm saying. And this is x minus 2 here. When you times in, is minus x plus 2. So I write minus x plus 2 straight away. And then I have another x minus 5. The result is 115. So let's simplify this further. This is 15x minus 17 minus x. Okay. Now, if you want to make it easier to expand, right, maybe you put the negative inside. As in, I do very slowly. I'm going to multiply the negative inside. This is positive x minus 17, x minus 5. Yeah, our brain works easier if you both x's in front. It's easier for us to expand and simplify. So this will give us 15x plus x squared minus 17 minus 5. That's minus 22, right? Okay. Minus 17 minus 5 minus 22. And then this is 85. The result equals 115. So the 15, you can minus 22, you're left with 7. 85 minus 115 is going to give us negative 30. Negative 30. And up to here, we can double bracket factorize them. Factor of 30, I can use 30 and 1, 15 and 2, 10 and 3. Notice 10 and 3 gives us 7. So this will be 10, right? This will be 10. This will be 3. The 10 is a minus. The 3 is a plus, right? So my x is either negative 3 or positive 10. Now, but we know x can never be negative, right? Imagine your length x is negative. Yeah, you can't have negative value. So we can straight away ignore x equals to negative 3. We take x equals to 10. Now let's sub inside equation number 2 to find your y value. Your y is 10 minus 2, which is 8. But we're not done yet. We're finding area of the pineapple. Pineapple means we need to take the length here, 15 minus y here, see this? And the width is x minus 5. So your area of pineapple is 15 minus 8. And the width is x is 10, 10 minus 5. So is 7 times 5, 35 square meter. Question number 14. So this is a Form 4, Chapter 2 quadratic function. So it gives a graph of quadratic function gx equals negative x squared plus bx minus 6. Yeah, they say by using the method of completing the square, find the value of bn. Okay, so first of all, before you complete the square, remember you need to make your coefficient x squared becomes 1. So if it's not 1, we factorize it. We take out the negative here. When you take out negative, remember bx, you also have to factorize bx. If I
take out the negative, I got negative px. Now keep the 6 outside. Now personally I like to keep the 6 outside because it's not involved in the process of completing the square. We only deal with, we need to work on the x square and x only. Now, number 2, we take half of negative p here, right? So half of negative p is negative p over 2. And you square it, you minus p squared over 4. I can square it straight away, guys. You take this term, p over 2, you square it. It's actually negative p over 2 square it, which is p squared over 4. Now, for those who will wonder, hey, Terry, why you have to put a negative here? Because when you expand this, right, this is a squared, 2ab, 2 times x times p over 2 is negative px. And then you have a p over 2 bracket square. If you square this, you should get p squared over 4. So the purpose of putting a minus here is to cancel out the last term, right? So when you put it in the form of, we call it a vertex form or completed square form, there is always an additional term here. So we subtract just to cancel it out, yeah? So to make sure that it is the same as the expression above here. Next, we take this negative and we multiply inside. So it's going to give us p squared over 4 minus 6. Okay, so now that I've completed the square, now we need to read the maximum minimum from the graph. You can see the a is less than 0. So your gx has a maximum value. And my maximum value is p squared over 4 minus 6, right? So if your p squared over 4 minus 6 is your maximum, we can compare the maximum from the graph. Your maximum is k, right? And okay, how about your axis of symmetry? Okay, maybe I compare my maximum first. We know your k is now p squared over 4 minus 6. However, I can't solve this yet because we have two unknown equation. We need more information, right? Now, we also know that the maximum happens. Your gx can only be this. Okay, we'll highlight for you. Your gx can only be this, right? If the one inside the bracket is 0. What is inside the bracket? Your x minus p over 2. So let's take this x minus p over 2, let it be 0. Your x is now p over 2. This represents your axis of symmetry. Now, if you look at your graph, your axis of symmetry is here. It's at x equals to 3. So we compare 3 is p over 2, p is just 6. So when you sub inside equation 1, your k is 6 squared over 4 minus 6. 6 squared is 36. 36, if you divide by 4, you get 9. 9 minus 6, right? Your answer is 3. Okay, I've got my p and I got my k, right? So the next thing is we want to find the coordinates of point B. Okay, now B represents your y-intercept. So let's just sub inside here. Now that I know my gx, okay, since it's quite short, I'm going to work it out here. My gx is now negative x squared. My p is negative. There's a positive here. P is positive 6. And then there is a minus 6. Now, actually, the value of the y-coordinate point P is independent of the value of P, because we know that at y-axis, your x is 0. If you put 0 inside x, the whole thing will be 0 except your negative 6. So this represents your y-intercept. So therefore, B has a coordinate of 0, minus 6. Okay, lastly, find the range of values of x if gx is less equals to 2. Okay, I know my gx now. I know my gx is this. So I'm going to put negative x squared plus 6x minus 6. I let it be less equals to 2. Okay, so what I'll do is I'll bring everything to the right. If you want to bring to the left also can. I know a lot of students probably prefer to bring to the left, right? And then they make this negative 8. But it's hard to factorize if this is negative. So what we do is we multiply everybody by negative 1. So this is the minus 6x, this is a plus 8, and we have to change the symbol. And so what we have here is a quadratic inequality. And to solve quadratic inequality, we have to sketch a graph. But first, we need to factorize this. What is a factor of 8? I should use 2 and 4. To get 6, I must use 2 and 4. Both are minus. Factor of 8, 8 and 1,
4 and 2, 4 plus 2 gives us 6. So I know my roots are, you let x minus 2 equals 0, x is now 2, x minus 4 equals 0, x is now 4, greater equals 0 is here, and here. So my x value is either less equals to 2 or greater equals to 4. So there you go. That's your range of values of g, of x. Okay, question number 15. So we're supposed to solve this equation, trigo equation, and this is from 5, chapter 6, yeah, trigonometry. So now, first of all, cosecant, as we know, is 1 over sine. So I'm going to write 1 over sine 2x plus pi over 6, right? And this is 2. So we can invert it. Yeah, some of you may want to skip the first step because we can actually invert both sides directly and write this as half. Now, the next thing is we need to find our reference angle. So we write 2x plus pi over 6. I'll put the REF there. Okay, use your calculator. This is in pi radian. So remember, you're going to change your calculator to radian mode. So I'm going to put shift sine 1 over 2. This is pi over 6. Okay, 1 over 6 pi. Now, if you don't have this calculator or the silver or the black and white one, right? So you will get 30, then you convert to radian. So if you shift sine of using, if you're using the 570 ms, you get 30 in degrees. Then you convert to this to radian by multiplying pi over 180. That gives us pi over 6. Okay, now the question didn't specify that you have to leave your answer in pi radian form or even in decimal. So it's actually okay if you want to leave decimal, right? So next step is this. We're given x is between 0 to pi. The moment you times 2, your x is now 0 to 4 pi. So you're going to double the number of solutions. See, normally we say, okay, one cycle is 0 to pi to 2 pi. But because you double the number of cycle, so your number of solution is also double, right? So another thing is, you are not starting at 0. You're starting at pi over 6. So I'm going to add pi over 6 on both sides. This is pi over 6. This is 2x plus pi over 6. This is 4 pi plus pi over 6. Now, if you want, you can just write this as 25 over 6 pi. Okay. Now, I just want to show you that now we, instead of starting, okay, just use this in first. Instead of starting at 0, I'm starting at pi over 6, about 30 degrees. So I go one cycle and I stop. I start from pi over 6. I stop at 2 pi plus pi over 6. All right. And the second cycle, I start from, let's say, 2 pi plus pi over 6. I go one round up to 4 pi plus pi over 6. Now, so happen that your reference angle is the same as this pi over 6. So when you consider the answer, right, see, this reference angle, it actually lies here, exactly on the line. And sine is positive in quadrant 1 and quadrant 2. So this one is pi over 6 as well. Quadrant 1, quadrant 2. Now, if you want, you can draw another one. So actually, there's overlapping here, right? There's overlapping here. So should I draw another one for you? Okay, as in. Okay, there are 5 solutions here instead of normal 4 solution. So I can draw another one to show you that this is 4 pi. This will be 5 pi. So if you include the 4 pi plus pi over 6, you'll be here, right? So pi over 6 here, pi over 6 here, pi over 6 here, right? Because you have to stop until 4 pi plus pi over 6. And you see it's inclusive, so you need to include this answer as well. So my first answer, 2x plus pi over 6, will be, the first one is just pi over 6. Second one is in quadrant 2. Let me use a blue color pen to show you. This is measured from here to here. We're finding the general angle from the reference angle. Your reference angle is pi over 6. Your general angle will be pi minus pi over 6, right? So then this one as well, this one as well. Yeah, and the last one. Okay, now let me just look it up. First answer, second answer is pi minus pi over 6. Next answer is 2 pi plus pi over 6, 3 pi minus pi over 6. Lastly is 4 pi plus pi over 6. I hope you know this, ASDC, all science teacher crazy. Only science teacher, not math teacher. The sign is positive in quadrant 1 and 2. That's why I put in quadrant 1 here, quadrant 2, quadrant 1, quadrant 2, another quadrant 1, because your sign value here is positive half, right? If it's negative half, then you have to take quadrant 3 and 4. So whatever we get here, you get a minus a pi over 6. The first one is very simple. Pi over 6 minus pi over 6 is 0. Okay, this one I will show you. Now, you can actually drop the pi because it doesn't matter. You just drop the pi in your calculator. When you key in your calculator, just drop the pi. So it's actually 1 minus 1 over 6. You minus 1 more 1 over 6. Okay, minus 1 more 1 over 6. Whatever you get here, right, you divide by 2. So when you divide by 2, you get 1 over 3. So the next answer is 1 over 3 pi. This will be 2 pi plus pi over 6. You can actually cancel this, right? So you get 2 pi divided by 2. 2 pi divided by 2 is just 1 pi. Okay, the next one is 3 minus 1 over 6 minus 1 over 6. You can just times 2. Whatever we get, you divide by 2. So what do you get here? 4 over 3 pi. And the last one, again, I can cancel the pi over 6, pi over 6. 4 pi divided by 2, answers 2 pi. So here we have 5 answers, right? And you need to include all 5 because all 5 are still between 0 to 2 pi. Okay? Okay, this is the first one, okay, first part. Now let's look at the second part. The second part, you have to use the sketch a graph, draw a graph actually. So normally, historically in SPM, it's always been sketching, not drawing trivial graph, okay? But this question asks us to draw, so I'll just draw it, okay? All right, so first of all, I'm going to draw y equals 1 plus sine x from minus 2 pi to 2 pi. So I hope you all know by now, when you draw a graph of sine, the basic sine graph looks like this. Maximum 1, minimum -1, this 0 to 2 pi. However, when you have a plus 1 or 1 plus in front, I'm actually shifting it up by 1. So when you shift up by 1, the graph goes like this. All right. So this is 1, this is 2, 0, y, this is 2 pi. Now, another thing is that the domain given here is up to -2 pi. So instead of drawing only the right-hand side, we have to move on to the left-hand side. So we go like this, and we extend to the left like this. Sorry, my graph is a bit ugly. So it goes down, up, down again. And this will be at -2 pi. This will be at 2 pi. This is 1, this is 2. So your graph should look something like this, okay? But here the question asks us to draw using the graph paper. And the scale is 2 cm to 2 pi, to pi over 2. So let's draw 2 cm to pi over 2, okay? Okay, since we already know how the graph is going to look like, right? So it's actually not necessary for you to plot the points, but anyway, I'm going to show you. I don't need so much space because remember I shifted up by 2, a maximum 2, minimum is 1. So my middle line will be around here. All right. Let me put here. Now my line is a bit thin. Maybe I could. Yeah, never mind. I'll just put it here. Right, this is my y-axis. All right, my line is not very straight. Okay, make it a bit darker. Okay, I hope this one looks better. Okay, it's not very good. It's too dark. So this will be slightly better, I hope. Right? Okay, put it here. Okay, now let's draw the horizontal line. So let's go from here to here. This point over here. Okay, need to adjust it. Okay, let's make it darker like this. Okay, easier to see. Okay, so now this is your x-axis, this is your y-axis. My maximum is 2, minimum is 1, right? And they ask us to use pi over 2. This is pi over 2, pi, 3 pi over 2, and this is 2 pi. We go to the negative side, is negative pi over 2, negative pi, negative 3 pi over 2, and minus 2 pi. Okay, so the graph has to go up, start from 1, from here, We go up. We know this is 2, right? Down, down, up. So we can go up. Okay. A bit ugly. I'm missing the point. So here, 2. Maybe I should pause, then go down. Okay, this part can be better. Still a bit ugly. Down and up. So this one go down. Not nice. Go down. This way. Well, can be improved. So especially hard you use this and to draw. Over practice, you get better. Okay, so my graph is done. All right. But for those who are not sure, say, hey, how do I actually know the points if I'm not sure how to draw 1 plus sin x? Okay, there is one tool in your calculator that can overcome this problem, right? So you press mode, you go to 7 for table, you key the function 1 plus sin x. Okay. Now your x is actually this alpha close bracket. All right. Then you press equals. Ignore gx. We don't need gx. Press equals. You start from negative to pi. All right, and you end at 2 pi. And the step in this case is pi. The step is an interval. So the step is now pi over 2. You press equals. See, you're given the first x value, you can see is 1, which is over here. Second x value is now 2, which is over here. The third one is 1 again, which is over here. The next one is 0, which is over here, and so on. So we can use this tool to actually help us to plot the graph on that. Okay? So it's not necessary in this case to draw table values because after all, we can actually draw this quite easily, right? Using we know the graph of sine, it goes up and down like this. Just have to use a graph paper to do it. All right. So I think that's the end of this paper. Yeah, thank you for watching. Hope you learned something from this video recording.